Hi everybody, welcome back. This is Mishler Math. We're going to talk about solving inequalities, okay? Inequalities. And solving inequalities is almost the same as solving equalities or equations, okay? So I'm going to show you, we'll start with a simple one here. Let's say negative 4 is less than 7 minus 3x. Well, obviously we want to find out what values for x, because a solution, remember, means what values for x is going to make this statement true. This is a statement. Negative 4 is less than 7 minus 3 times some number. So we want to find out what number will work and what numbers won't work. And so we're going to solve and graph this equation. So first thing I'm going to do is subtract 7 from both sides. Okay. So negative 4 minus 7 is negative 11. Sign stays the same. That's less than negative 3x. Now we have this neat little thing called the negative rule. And I'm going to make this in red so you remember it. The negative rule. Remember this. Okay? And the negative rule says real simply at this, if you multiply, this is a multiply sign, or divide, that's a division sign, okay? Remember, a fraction is a division problem. So if you multiply or divide by a negative number, then you must reverse the sign. And the reason I said that is because, look, in order to solve this inequality, I have to divide both sides by negative 3. Okay? So that means that I'm going to reverse this sign. I'm going to, instead of saying negative 11 over negative 3 is less than, okay, because this is going to gives me x over here. But I have to turn this sign around so it points this way now. And so I got 11 thirds is greater than x. Or x is less than 11 thirds. Now, you see what I did is I just swapped this, made it backwards. And the reason I did that is because when I graph this sort of thing, you know, and I make a number line here, and the reason I don't need a Cartesian plane here, I just can use a number line, because 1, 2, this is 1, 1, 2, 2, 1, 2, 3, and I'm going to have to stretch this a little bit further. Excuse me for a moment here, folks. Oh, look at that. Okay. 1, 2, 4. And the reason I did this is because I want to go 11 thirds, and I got negative 1, of course, and negative 2. I want to go to 11 thirds. I'm going to change colors here and make this a bright yellow. And this is less than, and so 11 thirds, first of all, this is 3 thirds, 6 thirds, 9 thirds, 10, 11 thirds. And so my solution is going to look like this, okay? When I graph the solution, I probably should have used that tool to give me a straight line, but you get the idea. The solution circles, this is 11 thirds, okay? And if you don't believe me, just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 thirds. And 4 is equal to 12 thirds. So we have 11 thirds, and we just shade this region here to the left of that, okay? And so what that means is every single number, and there are an infinite number of numbers, of course, every single number below 11 thirds is going to solve this. Anything over 11 thirds won't be a solution to this original inequality up here. Okay? This thing right here. So what that means is, let's try putting 4 in there. Negative 4, is that less than 7 minus 3 times 4? Okay. Well, what do you think? 3 times 4 is 12. 7 minus 12 is what? Negative 5, right? Is negative 4 less than negative 5? No, negative 4 is greater than negative 5. If you look at a number line, 0, here's negative 5, negative 4. Negative 4 is greater than negative 5. You see, it's not less than negative 5. So that is not a true statement. But if you put 0 in there, okay, try putting 0 in there. Change that to 0. Now 0 is supposed to be, that's shaded, so that's supposed to be one of the solutions. So is negative 4 less, so negative 3 times 0, that just gets rid of that. So, okay, is negative 4 less than 7? Of course it is. So 0 is supposed to be in the solution set. It is in the solution set. You can check any one of these other numbers and get the same situation. So let's try another one since we're so good at this already. And let's try this one. It's a little bit more complicated. 5 minus 7t is greater than 8 minus 4t. Okay, so this time I've got a variable term on both sides, so I'm just going to add 4t. Add 4t. Be careful how you say that so you're not adding 40. Anyway, it's 5 minus 3t is greater than 8, because negative 4t plus 4t gets rid of that one. Okay, those are gone. Negative 7t plus 4t is negative 3t. Now I'm going to subtract 5 from both sides. Okay, negative 3t is greater than 3. And now once again I have the negative rule, so I'm going to divide both sides by a negative number. I have t all by itself, because those two cancel, is less than, I had to turn the sign around. 3 over negative 3 is negative 1. So, okay, once again, let's graph that on a number line and take a look and see what we have. It'll be a little bit easier. 0, 1, 2, 3, negative 1, negative 2, and less than negative 1. So negative 1 is right here, and less than is an open circle. And I'm going to shade to the left, and there's my solution set. Now I'm going to double check. Start with the easiest one. Start with 0. Put 0 here. Say 5, and I'm checking here, so let me see if I can get a different color. 5 minus 7 times 0, is that greater than 8 minus 4 times 0? So of course multiplying by 0 gets rid of both of these. That's why I'm saying it's greater. Use 0 because it's easy. Is 5 greater than 8? No. Okay, so 0 as a solution is not supposed to be a solution. Look, it's not. It's not shaded. How about negative 2? Is negative 2 a solution? Let's try negative 2 in a little bit different color. So negative 2, let's see, 5 minus 7 times negative 2, is that greater than 8 minus 4 times negative 2? And so let's see, 5 plus 14, is that greater than 8 plus 8? So this is 16 over here, and this is 19 over here, and so 19 is greater than 16, and so yes, we have a winner. Negative 2 is supposed to be a solution, and negative 2 is part of the solution set. It's shaded. So that being said, let's try another one. This is a little bit trickier because this is called a compound. Isn't that fancy, what I just did there? Don't ask me how I did that. This is a computer. It thinks on its own. Compound inequality simply means that I'm going to, I've got two expressions here, or two inequalities. So 2x plus 5 is greater than or equal to 3. And x minus 5 is greater than negative 12. Now it has to solve both of these because of this word here. It has to satisfy both of these conditions. So I need a value for x, okay, that makes both of these statements true. So let's see how that works out. I'm going to subtract 5 here and subtract 5. So I have negative 2x greater than or equal to negative 2. Now I divide by negative 2, and I have x is less than or equal to 1. Well, why'd you turn the sign around? Because of the negative rule, of course. The negative rule, by the way, only works when you're multiplying by or dividing by a negative number on both sides. That's the only time you use the negative rule. Don't be using the negative rule. Don't be switching signs every time you do anything. Make sure it's only for negative numbers, okay? So let's add 5 here. Add 5. And x is greater than a negative 7. So in other words, x has to be less than or equal to 1 and greater than a negative 7. Let's see how that works on the number line. Let's create a number line here. And I'm going to put a 0 here. And this is negative 5 and negative 10 and positive 5. And so 1, 2, 3, 4 in between there. 1, 2, 3, 4 in between. There's 5. And 1, 2, 3, 4 in between there. And if you want to get fancy, 1, 2, 3, 4, and 10. There we got a nice, beautiful looking number line. So x is less than or equal to 1. Because it's less than or equal to, we use a solid circle. And because it's greater than, we use a open circle. So we connect those 2 points. That's all. We connect those 2. So, is 5 a solution? Let's see if it works in both of these. Negative 2 times 5 would be negative 10, plus 5 would be a negative 5. Is negative 5 greater than or equal to 3? No, it's not. So it doesn't work in that one, so it can't work in it doesn't matter if it works in the other one. It has to work in both of them. Let's try negative 10. Negative 2 times negative 10 is positive 20, plus 5 is positive 25. Is that greater than or equal to 3? Of course it is. Let's try here. Negative 10 minus 5 is negative 15. Is that greater than negative 12? No, negative 15 is less than negative 12 because it's to the left of negative 12. And so it doesn't work in this one. And so if it doesn't work in either one of these, it can't work. How about negative? Oh, let's try 0. That's an easy one. That gets put 0 in here. That gets rid of that. Is 5 greater than or equal to 3? Yes. Let's make sure it works here too. Is 0 minus 5. Is negative 5 greater than negative 12? Yes, it is. Negative 5 is here. Negative 12 is over to the left of negative 10. So negative 5 is greater than negative 12. So if I use 0 as if I make x equals 0, then it works. And sure enough, it's shaded there, so it's supposed to work. Okay? And so one more time, we're going to try one more inequality here. And let's see what we have here. We have it's very similar. It's another compound inequality. 2x less than or equal to 5 or 7x plus 1 is greater than 36. So it has to be one or the other. And you say, well, how does that work? Well, let's see. So x is less than or equal to 5 halves, which you know is 2.5, or subtract 1, 7x is greater than 35. Divide both sides by 7. Look, this is not negative, so we're not going to use a negative rule. So x is greater than 35 over 7 is 5. So x is less than or equal to 5 halves, or it's greater than 5. So let's draw our number line down here and see what we end up with. And we have, I'm going to put 0 over here because we're going to be on the positive side. So 1, 2, 3, 4, and 5. So x has to be greater than 5. So there's open circle and shade to the right. So that's the x greater than 5 business. X has to be less than or equal to 5 halves. Well, that's 2.5. This is 5 halves. This is 2. 1, 2, 3, 4. So this is 2.5 right here. So that's a solid circle because I got less than or equal to. So I put that there, and I shade all the way to the left on that. So there's my graph of that particular solution. You see everything less than and including 2.5, okay, and everything greater than and not including 5, okay. So x is greater than 5, x is less than or equal to 5 halves. And I will let you go through and check those and make sure, pick a couple points on here and see if they work. And if they work, then you know you have a good solution. That's it for now. See you in class tomorrow. Thank you.